MHP. Welcome back to another exciting video from Mr. Carlson's Algebra 2.2 class. I'm excited, sort of. So we are going to review. Let's just get right into it. We're going to review the syllabus once more, just kind of recap some important concepts, expectations I have for you, even online. I'm going to go through the objective and essential question that's very, very important because this is your very first algebra lesson. Well, technically it's Algebra 1 review, but still an Algebra 2 lesson. So you should be taking notes. You should be getting a notebook paper out. Pause the video right now if you need to. Get some notebook paper out. Get some graph paper. Start taking notes if you need to. Well, you do need to. And write down as much stuff as possible. Okay, I'm gonna have steps on the screen here. I'm gonna write out all the work and everything. I'm gonna try to be as elaborate as possible, as vivid and clear as possible, because that's my goal. If you don't understand something, just rewind, play it over again. If you still don't understand it, go ahead and send me an email. If you still don't understand it, then please set up a tutoring time so we can kind of hash this out. And so I want to be able to mesh well with you guys. I don't want any blockage here. So please get to know me as I get to know you, and even email me. Yes, even email me, just so that you can get to know me even if you have questions. Okay, after we go through the solve linear equations and inequalities, I'm going to do the closure, summary, and homework, and so forth. I'll probably show a little bit more of Google Classroom just to recap from yesterday's video. I'll also probably go over homework from Math Excel as well, because today starts your homework on Math Excel. You will have a literal lesson on Math Excel called Solving Linear Equations and Inequalities. If you're in honors, you're going to do the honors one. If you're not going to do it. So let's get started here. I'm kind of excited. So, first thing is first. Go ahead and write down the essential question. You don't need to write down the objective here. Don't feel the need to write down the objective. This is the objective that I can review. This is the essential question because it has a question mark, right? So that is something I'm going to be looking for in your notes when you upload them on your pictures on Google Classroom. So just to recap a couple things as you're writing it down, remember your syllabus is due, your acknowledgement form is due Wednesday, 8/5 by 4 p.m. Just fill out the acknowledgement form. That would be great. Another couple things to remember, you do have a homework quiz of this lesson tomorrow. Or if you feel like this lesson's super easy and you want to go ahead and do the homework quiz right away, that's fine too. Absolutely go ahead and do that. But I will have to explain some things, and I am planning on explaining how the homework quiz kind of goes and how I kind of structure it. Even though, yes, it's a quiz on Math Excel, I still kind of ask a couple more things of you to maybe help you out a little bit. So if you want that help, then just pay attention to the next video tomorrow if you're watching it, or just the next video online. Okay. Other things, as you're writing it down, finishing up, remember that you need to be on Google Classroom like now. You need to be on Math Excel, obviously, like now. If you're not on Math Excel, that is a problem. If it's Tuesday, 8/4, that's a problem if you're not on Math Excel. You need to communicate to me ASAP. Right now, stop, pause the video, communicate to me, send me an email. Hey, how do I get on Math Excel? Or hey, I need an access code, and I will email you back and I'll help you out as much as possible. It's way better though if you go to the Google Meet link from 10 a.m. to 11 a.m. Okay. Last thing, remember homework quizzes are worth small percentage of the grade. It's about 10 out of 10 points. Remember, if you do this homework, this lesson, you'll have a homework assignment attached to it on Math Excel. If you do that homework assignment at 100%, okay, at 100%, then when you take the homework quiz right after or the next day or whatever, and let's just say you missed a question, because you completed the homework assignment on time before the homework quiz at 100%, I will give you 2 extra credit points towards that homework quiz. Okay, which means if you missed a question on the homework quiz, guess what? You just got it back. because you were awesome and you did your homework. Also, remember, I will be checking your homework as a participation grade for the week, not in the individual grade, but I will be collecting your participation grade for the week and so forth. Okay, so I kind of summarized a lot of stuff there. If you have any questions, just let me know. I will be reminding you over and over and over again what to look out for, what you got going on this week, and so forth. So, you have a quiz this week. So that's exciting. You have a quiz on Friday, the Algebra 1 quiz review. You have a Desmos activity that's supposed to be done. So if you have yet to do the Desmos activity, the intro to Algebra 2, go back to day 1 video and start watching that, because I'll explain that Desmos activity. That's due. You'll have another Desmos activity later on this week, and a quiz review as well. So we only have 2 real lessons, this one and then tomorrow's lesson, absolute value. Those are the only 2 lessons, actual lessons where I'm teaching you this week. All the rest is just kind of participation grades and a quiz, as well as the homework quiz. As I'm kind of showing you these steps, as you're writing them down, I'll be talking about your algebra pretest. So if you have yet to complete that as well, make sure you do that. Go ahead and pause the video because I'm going to show you on Math Excel real quick. Okay, so remember this Math Excel orientation you do need to complete by 8/7 by 4 p.m. I need 100% on that. Remember something like that. This 9x is going to be chilling here. I'm not going to touch that. And then minus -1 times 6x is minus 6x. -1 times -4, a negative times a negative, positive. And then that becomes a positive 4 because 1 times 4 is 4. Negative times a negative gives me positive. And then the 19 is just chilling. All right, we have a couple things we need to simplify here. So I'm going to get a different color and try to simplify. I can combine this stuff right here, and I can combine this one, these two. So these are the constants, the boxes are the constants, and these are my x's. These are called like terms, if you remember what they're called. That means I want to combine like terms. You remember that from Algebra 1? I hope so. 9x minus 6x is 3x. Now what do I do with the plus 4? Well, the plus 4 needs to combine, technically. I'll kind of move it down here. I won't usually do this type of math, but I need to subtract the 4 over, because what's the opposite of addition? Subtraction. Why do I need to do the opposite? Because I need to get this 3x by itself. Okay, that's what I'm trying to solve for. I'm trying to solve for x. What is x? Okay, so I do that. That goes poofy, and then I'm left with 3x because I didn't do anything with it, so that just gets brought down. 19 minus 4 is 15. I divide by 3. Why do I divide by 3, Mr. Carlson? Because this is multiplication. I did a little dot there. It's a multiplication sign. What's the opposite of multiplication? Division. Okay, so I divide by 3 to both sides. That goes poofy, which means I'm just left with x. So what's my final answer? X equals 15 divided by 3 is 5. That is my answer. Smiley face. Smiley face. Okay? So technically I did distributing right here. Whoa, that's an error. I simplified right here. I separated the terms around here, and then I'm isolating it right there. Okay, that's literally boom, 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 boom. Simple, short steps. Go ahead and pause that if you need to have more time to write it down. Again, this should be review. So if you're totally like, whoa, what did he do? You need to come communicate to me like pronto. Okay, because that is technically review here. Now this is pretty scary, and I definitely want to go through this one. You're like, that's not review. Well, technically it is. Okay, but it is a little bit more complicated because obviously there's fractions involved. So I'm going to break it down really quick. I'm still going to follow the same steps here, guys. But the first thing I notice is that there are fractions and there's x's just kind of attached to the fractions. So I'm going to make it a little bit more clear by doing little dots. Why am I doing that? Because this is multiplication. I want you to understand that the x is multiplied by that whole fraction. So this x is multiplied by this whole fraction, 5/8. That x is multiplied by this whole fraction, 1/16. Okay, there's no x attached to here, but there's a plus x over on the side. That's fine. Okay, so first things first, I have two terms on one side that can be combined because they have like terms. They both have one single x. And you're like, well, they don't have the same denominator. You're right, which is why we need to simplify. There's no distributing here because there's no parentheses, so don't do that. But I do need to simplify. Okay, how do I simplify, Mr. Carlson? Great question, kids. You need to find common denominators. The common denominator here should be 16. Okay, it's not 8 because 16 cannot go in 8. But hey, 8 can go in 16, and hey, 16 can go in 16, right? They can divide evenly. So I see that 8 is a multiple of 16, so I can just multiply 8 by 2, and I get 16. That means what I do to the bottom, the denominator, I must do upstairs to the top, the numerator. So 5 times 2 is 10. So what are my new fractions here? My new fractions off to the side here. Actually, I'm going to do it way off to the side so I don't waste my room. Is 10 all over 16x, don't forget the x, plus 1 all over 16x. That's my new left side of the equation. And then, equals blah, 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 just this stuff. I'm not going to touch that right now. I'm going to focus on this. How do I do this? Okay, well, when you have fractions, you just add across. If you have the same denominator, when you're adding or subtracting, that's what we did. When you have the same denominator, the common denominator, then you can just look at the numerator and then go straight across. So what is 10 plus 1? It's 11. And then you keep the denominator the same. What happens to the x? Let me ask you a question. What is 3x plus 2x? If you say 5x squared, I'm going to get really upset. It should be 5x, okay? So this is kind of a side note here. Now, if I look at this x and that x, and if I add two coefficients, that's what they're called, coefficients, the number attached to the x. If I have two coefficients, I added them, just like these fractions here. What happens to the x? Well, it just gets tagged on, right? Same thing here. Okay? I went through that pretty fast. Again, this is algebra foundation. What I did right there is algebra foundations. Okay? So I don't want to spend too much time in an Algebra 2 class doing that. However, if you're still kind of fuzzy, by all means, absolutely email me. I want you guys to feel free to email me, even if you don't understand. Just email me saying, hey, I don't understand the first example that you did here. Even copy the link this at the current time. Just all you have to do is go to YouTube, right-click, copy link at current time, go to my email, paste it, say, yo, what is going on here? How did you do that? I'll try to explain it in a different way. If you want to do that, perfect. Send it to my email. Okay, so that means I just did all of the left side here. So all of that combined. So all of that combined right here, and now equals that. So that means this equals the right side. And the right side, I literally haven't touched at all. So I'm just going to copy it down. Okay. Now, I still have a couple things I need to combine. Remember, I need to get the x by itself. The x is not by itself. So I need to take this x, and I need to move it over to the other side. How do I do that? Well, I need to balance the equation. I need to basically cancel it out or take care of it on the right side. Well, how do I do that? Well, I do the minus x. So that goes poofy, and then minus x right here. What does that look like? It's going to look like this, so don't freak out. At least not yet. It's going to look something like that. Okay? See, the minus x is now over here and not there. It's magic. Okay. Okay, so how I combine these, don't freak out. They're still the same like term. So how I combine them is, again, common denominator. So this is technically 1 all over 1. That's the coefficient here. 1 all over 1. So I'm going to change to a different color. Let's just go to red here. So 1 all over 1. So I need to make sure I get the common denominator. So that means I need to times this 1 by 16 to get 16. I times that 1 by 16 to get 16. So what does this actually look like? This actually looks like this. And by the way, guys, I usually don't take this long to do a problem like this. Okay, that's what I have. I'm actually going to erase this right there. Okay, so, and then what I have on the other side is 7 all over 16. So notice how they're all 16s, right? So now what I can do is the exact same thing here. I can just go straight across with my numerators. So 11 minus 16 is 5, negative 5, because the negative is attached to the bigger number. So negative 5 all over 16. And then I still keep the x. This equals 7 all over 16. Okay? How do I get rid of all this? It's actually pretty nice. I'll try to do like a bluish. I actually have to multiply this by something. It's called the reciprocal. Why am I multiplying this side rather than that side? Because again, your goal is to get x by itself. No numbers attached to it. You don't want any numbers attached to it, so you need to manipulate the equation in your favor in order to get x by itself. Okay, that's what the logical structure is. That's why math is so fun. Okay, so I need to take the negative with it, so I'm going to just take a negative, and I'm going to basically kind of invert this equation, so 16 on top and then 5 on bottom. Now, if you're saying, well, Mr. Carlson, why is the negative not with the 5 when it's over there? It doesn't matter. You can have a negative 5 like this. This also equals this. And this also equals this. They all equal the same thing. Negatives on top, negatives out front, negatives on the bottom. They all equal the exact same thing. So it doesn't matter where you put this negative, as long as you have it. Okay? So what happens to the 16s? They go poofy. What happens to the 5s? They go poofy. And the negatives are still chilling there. What's a negative times a negative? Positive. Okay, so what's left? X. That's exactly what we want. But here's the thing. What I do to one side, I must do to the other. So I multiplied the left side by negative 16 all over 5. That means I must multiply the right side by negative 16 all over 5. That same reciprocal. So what happens here? Well, the 16s still go poofy. Negative? Yeah, it still stays a negative because there's no negative here to kind of cancel that negative out. So that means this negative is attached now. And I have 7 all over. What happens to the 5? It goes right on bottom. Okay? Now, again, if you totally understand this, you can kind of skip past, but I'm trying to belabor this point. Some of you are maybe thinking, what? How does that happen? Well, think of it like this. I'll kind of zoom up on this a little bit bigger here. What I did here was this. I went poofy, and I had the negative. So this equals, so far, 7. Now watch what happens. All over 1. This will technically become a 1, and that will technically become a 1. Times negative 1 all over 5. That's technically what happened. So then what happens with the negative? Well, it goes out front. 7 times 1 is just 7. And then 5 times 1 is just 5. That's exactly what I got here. Okay, so I'm trying to show you how fractions work. If you are struggling with fractions, you need to contact me. That's just, you won't survive this class, unfortunately, because it is an upper level math class. It's an upper level algebra class. You won't really survive, at least greatly well, if you don't understand the fractions. Okay, but most of you do understand the fractions, and that's great. But if you do need some extra help, by all means, please communicate that to me. That would be wonderful. All right, I'm going to erase. All right, let's go through this one. I'm going to go a little bit faster. I see a lot here that I need to distribute. So I see I'm going to distribute this. Eventually, I'm going to distribute this. This is my equal sign, so I need to make sure, okay, that's my equal sign. I'm now going to the right side of the equation. I need to distribute that. So let's go fast with this. 9 times x is 9x. 9 times 3 is 27 equals. 6 times x is 6x. 6 times negative 3 is negative 18. Plus 3 times x is 3x. And the 3 times 15 is plus 45. Okay, a lot of things I can do here. Lots of stuff. So I'm going to try to pinpoint what I need. First of all, I can't really do anything. I can't really simplify anything by itself, because now I'm simplifying. Can't simplify anything by itself on the left side. But I can simplify stuff right here. So I'm going to combine the constants together. That's what I'm boxing. and I'm going to combine the x terms together right there. That's why I'm underlining. So what do I got? So 6x plus 3 is 9x. And then 45 minus 18 is actually plus 27. So what do you see here? You're like, oh my gosh, that's crazy. What's happening? This is a very, very special equation. I want you guys to star this. It's a very special equation. Okay, it has a specific name. I need you to understand that. However, before we do that, technically you could still minus the 27 over. Minus the 27 over. That goes poofy. That goes poofy. You have 9x equals 9x. Divide by 9. Divide by 9. So you have x equals x. Is that a true equation? Yes or no? That's your important question for the day. Does x equal x? Do you equal you? Does a cow equal a cow? Okay, does my cat equal a cat? Obviously, yes. This is a true equation. When it's a true equation, my answer is then called infinitely. That's an N, sorry. Infinitely many solutions. My handwriting would be so much better if we're on the board, I promise. Okay, I actually have really good handwriting. Boom. That's my whole answer. You're like, that's not a math problem. It is actually. That means that this equation is true no matter what. Whatever you plug in for x, okay, if you plug the same number into both sides of the equation, you'll get the exact same thing on the left side as you do on the right side, no matter what. Pretty cool. That's important because you will see some of that. So we really didn't need to separate or isolate here because that's really nice. All right, let's erase. All right, let's go to town on this one. Let's go fast. So this is just multiplying here. I'm just distributing. And then remember, this is an understood one, so I need to distribute that one through. All right, what is going on here? So this is 4x minus 20 minus 5x and then plus 20. This will equal x plus 4. That's just chilling. It's not doing anything, right? Negative 1 times x is negative x. Negative 1 times negative 3 is positive 3. Got a lot of stuff that's happening here. A lot of stuff. So let's simplify. First of all, I can simplify these things on that side, and then this with this. Before I go to the right side, what do those equal? Negative 20 plus 20? That's the best thing that can happen, right? What's 4x minus 5x? That's a negative x. You could put the 1 here, negative 1x, but no one ever does that, so you don't need to. And then what else happens here? Well, you see a positive x here and a negative x there, so that goes poofy. And then I'm left with 4 plus 3, which is 7. Great. Now my next step is technically to separate. Sorry. So I need to technically divide by negative 1 here. Divide by negative 1. Negative divided by negative is a positive. I get x equals negative 7. That's my final answer. Ha! Now, sometimes Math Excel will say, hey, check it. What does checking mean? It means if I plug this x back in for that x, that x, that x, and that x, it should work out. What I mean by should work out, well, I mean it will work out, but what I mean by work out is just this right here, this whole left side of the equation will actually equal this side of the equation. That's what that means by work out. So if I plug negative 7 in, this side will equal that side. That's how I know I have the right answer, a true equation, right? However, you don't need to technically check. If you did your algebra correctly, you're solid. All right, let's erase. So that's it technically for linear equations. Now we're going to transition into linear inequalities. Inequalities are basically the exact same thing. It's the only difference is that you're going to do one special thing depending on the problem you get, and you also have greater than or less than signs, less than or equal to signs, and so forth. I hope you guys remember that. So you basically solve it the same, but then you have different kinds of signs, different, not an equal sign, but like a less than sign or a greater than sign. In addition to that, there's many different ways you can what we call represent your solution. Okay? So you can represent your solution in a completely different way if you want to. 3 ways, actually. I'm going to teach you those 3 ways. All right, so solve just like equations. Don't forget, you multiply or divide by negative. You flip the inequality sign. That is the most important part. So this is something that students love to forget. If you multiply or divide by a negative, have to flip the inequality sign, because then it changes, the whole number line changes. So instead of the number line being on this side, once you divide by negative, it technically becomes a positive, which means you have to go on this side. And so you basically flip over and over. That's why you flip the sign. It's necessary to flip the sign here. And then we're going to represent our solution in 3 different ways. So the first way we're going to do it is called set builder notation. It's actually very simple. It looks scary. It's really not. A set builder notation to express the solutions. We're going to graph it on the number line. This is actually, you've already done this. This is your Algebra 1, what you guys done with Algebra 1 all day long. I'm sure you'll remember it once we start going through it. And then this is actually new, so I'm going to have you guys star this. Depending on if your Algebra 1 teacher actually taught it, it could technically be review, but most of the time when I teach it, most students are like, yeah, I have no idea, so it's technically new. And so I'm going to explain that as we go. So I'm going to give you this inequality. Notice how it's not an equal sign in the middle, it's a less than sign. If you're like, how do you know it's a less than sign? If it looks like an L, it's therefore less than. Okay? If it looks like not an L, it is therefore greater than. And I'm just going to abbreviate great. Okay? They kind of look like sideways happy faces. What this little thing is, the equal to and then the arrow, that just means entails or implies. So that's all it means. So if it looks like an L, like this does, then it's less than. I was taught that by my grade school teacher, and it stuck with me ever since. So hopefully that will help you. If you want to do the alligator thing, like, oh, the alligator gets the biggest number, okay, go for it. Okay, 9 times 4 is 36. 9 times negative 2 is negative 18x. Don't forget to add the x in there. 9 times negative 2x is 18x. Plus 7x, that's just chilling off to the side. Now, less than, because I'm just reading the problem. Reading it. Less than 6 times 8 is 48. And then plus 6 times 3 is 18. 18x. Sounds good? Good. All right, let's start combining stuff here. I can combine this stuff. So I'm going to keep the 36 just chilling here. Negative 18 plus 7 is negative 11x. And then I can't combine anything on the other side, so I'm just going to kind of write it down. Just copy it down. Now I can start combining stuff. So let's start combining this stuff. First of all, I want this 18x all the way over here to combine with that x. And I want this 36 combined all the way over here to be with the 48. Now, the reason why I do these arrows like that is because, again, this is a higher level math class. I'm not going to show you the the minus 36 over and over and over again. Okay, that's ridiculous. I need room to work and everything. Of course, obviously, I could just erase it, but it takes up time. So I'm telling you this so I don't have to keep saying. I usually, when I solve basic inequalities or equations like that, I usually show students that needs to move over and that needs to move over. And that should therefore register in your mind that I am going to subtract 36 because that's a positive right now, and I'm going to subtract the 18x because that's a positive. Whenever I move it to the other side, I need to do the opposite sign for what it is. So what do I have so far? So I don't confuse any of you, this is what it looks like, okay? And then I have 48 and then minus 36. That's what it looks like, okay? When I kind of did the switcheroo there. All right, now, constants on one side together, x's on one side together. What is this right here? That'll actually equal negative 29x. And then less than, what will this actually equal? This is 12. Now, if you're wondering, well, Mr. Carlson, didn't you move a negative over to the other side? Don't you have to flip the inequality sign? No. What does it say? Multiply. What does that say? Divide. Have we multiplied anything or divided anything? No. We are now. So right now, we are going to actually divide by negative 29. And I'm going to divide by negative 29 because I need to get x by itself. So that goes poofy. Now, what does this mean? I have x. What happens to this inequality sign? Greater than, okay? It flips like a pancake. And then what happens here, I can just put the negative on top, negative 12 all over 29. So this is my final answer. Yeah, fantastic. So technically, kind of stinks that I don't have black here. You notice that? It's just the rainbow colors. What if I just wanted black? Lame. So 1, this is my first step. I solved. This is technically step 2 down here. Let's go to step 3 right here. Step 3, what is step builder notation? I'm going to show it to you, and then I'm going to read the math as you would like in English. Because math is a language, guys. Yes, it is. I just need to teach you the language. So I'm actually going to just show you the equation, show you the sentence in mathematics, and then I'm going to read it in English and what it is. And honestly, I'm going to then tell you what you need to do on Math Excel. Okay, this is what it'll look like. What does set builder notation look like? Looks something like this. So what does this mean? Well, first off, this is my answer. Second off, I'm going to show you what it means. You should see on your keyboard, right above your brackets, right above the enter key, you should see 2 things. You should see a bracket that looks like this, but you should also see something that looks like that. This is what we call a brace. Okay? So brace. This, of course, is what we call a bracket. So what does this mean? It means I'm going to use the brace to say this. This is the English. This is what it is in math. Ready? The set of all x, the set, follow along, I'm going to kind of trace it. The set, that's what the brace means, of all x, such that, so the vertical line literally means such that, x is greater than negative 12 all over 29. I'll do it again. The set of all x, the set of all x, the braces meaning a set builder notation, that's what it means. The set of all x such that x is greater than negative 12 over 29. So that's what it means, okay? Now, what it actually means is you have a variety of solutions. Okay, you have actually a ton of solutions, almost an infinite amount. So, step 4. What will this look like on a number line? This is your Algebra 1 days. Are you ready for this? When you would do 0 here for reference, and then you would do the answer that you just solved for. Maybe you guys remember this, maybe not. And then you would say, oh, since it's a greater than sign and it's not equal to right here, it's going to be an open dot. Remember that? And then we ask, okay, where do we shade? Well, we shade wherever it's pointing. So wherever this sign right here is pointing, look at this. If this was the tip of an arrow, where is it pointing? To the right. Okay? To the right. So it's pointing to the right. Pointing this way. Okay? I think. But it's pointing to the right. Now, since it's pointing to the right, I'm going to shade all the way to the right. Does it ever stop? No. It goes all the way to infinity. Sometimes you'll see this. You'll see a parenthesis here. Why? On Math Excel, you may see like a parenthesis there. And so I'm going to tell you why right now. It has to do with interval notation. What is interval notation? Interval notation is, again, another way to tell the reader of mathematics and the doer of mathematics, you guys, how to represent the many, many, many solutions of your inequality. So if I said, what's the answer? Technically, this is the answer, and I can represent it in this way. I can represent the answer also in this way, visually, what it looks like. That means all of these numbers, even 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to infinity, all of those numbers, even -1 here, well, actually not -1, sorry, because that doesn't go past -1, but maybe like -1/4, probably. -1/4 is maybe there. Okay, all of those numbers go all the way to infinity. That's what that means. So when I'm trying to do another representation called interval notation, what that means is I'm going to find my domain, the set of all x, get it? The set of all x, and where it lies. So I want to ask you one important question. I'm going to do this in red here. You ready? One important question. Let's go. Ready? Pay attention. Imagine this is the number line, okay? And it goes all the way over here, all the way over there, okay? Imagine that's a number line. Your important question is this. Does your shading exist and start all the way over here? Your answer should be no. In Spanish, it should be no. Okay? It does not exist right here. There's no blue shading here. Is there blue shading here? No. Is there blue shading here? No. What about here? What about here? No. Where's the blue shading? Right here. What is that number? -12 all over 29. Okay? Is it less than, or is it greater than or equal to, or is it just greater than? And your answer is it should just be greater than, which means I'm going to use what we call a parentheses to signify that it is not equal to. It's not included. I'm going to explain that in a bit. We're going to put a comma here called going to. That's what a comma is. It literally will mean going to. I'm teaching you the language of the math. And where does this head towards? Does it ever stop? No, Mr. Carlson, it never stops. Where does it stop? Probably infinity, but it will keep going on forever. You're exactly right. It will go all the way to positive infinity. And I'm going to put another parenthesis here. This is my interval notation. -12 all over 29, comma, infinity, positive infinity. Now, I'm going to make something extremely clear. This is not an ordered pair. Okay, what you just did is not an ordered pair. An ordered pair is like 3, 4. And you're like, well, there's numbers here and there's parentheses. No, infinity is not a number, it's a concept. Okay? So this is not an ordered pair at all. And the reason why it has parentheses is not so you can graph it like a point here, and it's like a relation between the x and y axis. That's what a point means. What this is saying is that it doesn't equal -12 to over 29. I don't have a closed dot here. It's technically open. And so I'm going to use parentheses. Now, why do I have parentheses over infinity? Let me ask you a question. Are you ready? Can you ever equal infinity? No. Good luck. Try counting to infinity. If you ever counted to infinity, man, I'd be a millionaire. Okay? I bet you $10 that you will never be able to count to infinity. Try it. Now, why am I using parentheses? What's the significance of this? I'm going to put it as a little note here. If I use brackets here, which I didn't, okay, that means that it is included. Okay, that's what that means. If I use parentheses in my domain interval notation, that's what we just did, interval notation, this means not included or not equal to. And I'm going to abbreviate here and just do include. Okay. I'm not going to put E. All right, so that's what it means. If I'm going to use parentheses, which I did, that means not included. It's not equal to. It actually doesn't hit that number on the x-axis. And that's true. And even infinity, it never really equals infinity. That's a technicality. You can never equal infinity. Okay, so it's a parentheses. If it's bracket, though, and we will have a couple of those, if it's bracket, that means it is an inequality sign saying equal to. I hope that's really clear. Okay, I hope that's extremely clear there. Again, rewind it if you need to. We're going to go through so many more examples, so don't freak out, don't worry. This is your interval notation, this is your number line, and that is your step builder notation. Each of these can represent your one answer, this. Great. Let's erase. Let's go through a different example. I don't think this one will have fractions, so don't worry. Solve it just like normal. So step 1, solve it just like normal. I'm going to look for parentheses so I can distribute. I'm not going to do anything right here. I'm actually going to move it just a tad bit over to the left. So 10x and then plus 2 and then greater than. This will be also 10x. 5 times 2x is 10x. And then plus 5, because 5 times 1 is 5, minus x. And then you have plus 5 here. Let's start combining stuff. I'm going to keep this 10x plus 2 chilling on the left side. These x's combine to be 9x, and the 5's combine to be plus 10. Let's start combining these two together. So remember, I'm going to just do the arrows, and then that goes over here. So 10x minus 9x, when it goes over to the other side, is just regular x, greater than 2x minus, when I go to the other side, when I subtract it from the 10, will just be 8. So this one is not as scary as a fraction as the other one. Great. Did I have to divide by negative in this one? No. So I didn't even need to do that one. That's great. Let's go to step 3. Step 2 we skipped. What does step 3 look like? Set builder notation. The set, fancy brace, of all x such that, that's what the line is, and then x is greater than 8. Fancy brace. Now, you're probably wondering, this doesn't help me at all. It will actually, because in Math Excel, it's going to want you to put this one thing in. So it will have like a template, kind of, for you, everything in red. For step 3, it will kind of have everything in red here as a template. But what's in green, this thing, the x less or greater than 8, x is greater than 8. What's going to be that is the thing that you put into Math Excel. So this in green is the thing that you'll put in Math Excel. Everything else will be kind of a template there. So don't think that you actually need to type in the brace, the x, and the vertical line. You don't need to do that. I think you just need to type in that thing. So that's great, right? I hope. Okay, step 4, what is it? Number line. So let's draw our number line out. All right. I usually do a 0 for reference. Let's do 8 right here. It doesn't matter. You can do all the other numbers in between. Go for it. I'm not going to. Is it equal to or not equal to? Well, it's greater than, and no equal to sign is below it, so that means it's open dot. Where is it pointing? It's pointing to the right again as well. Since it's a open dot, we're going to be using parentheses here, which means when I go to my interval notation right here, I'm going to be using parentheses. Where does the graph exist? That's the first thing that you ask. Where does the graph start existing? Does it start existing at 0? What about at 1, 2, 3? No. It starts existing at what number? 8. So it starts existing at 8, and I put a parentheses there because it's an open dot. If this was a closed dot and I could actually circle it in, if that was equal to, I would put a bracket. Since it's not a bracket because it's not closed dot, I will be putting a parentheses here because it's just greater than. The comma means going to. So 8, look at our number line, 8, going to what? Read math left to right. We read it left to right. Left over here, starts here. Where does it head to? Positive infinity. Boom, done. That's what it looks like. Okay? These are 3 ways: set builder notation, number line, and domain interval notation to all represent the one answer that you found to be this. X is greater than 8. All right. Let's continue on. This is going fast. I'm going to erase. This one looks a little bit complicated, but I assure you it's not. So just pay very close attention. We're still going to distribute. That's what that D is for. So let's distribute here. The 1/2 is still a number that I can work with. I need to distribute that to the 6y. And then the 1/2, I need to distribute that to the 2. Same thing here. The negative 1/3, this number I'm highlighting. You see that? Negative 1/3 needs to distribute to the 6y here, and the negative 1/3 needs to distribute there. Now, I'm going to show the whole process out, even though I don't really want to because that will take a lot of time, but I will just for those who are not strong with their fractions. If you're strong with your fractions, you can go ahead and kind of push the video and just fast forward the video. So what will this look like? This will look like 1/2 times 6y. Okay? And then plus 1/2 times 2. And I'm using parentheses here for timesing. This is minus 15 because remember this is still minus 15 there. It's just chilling. This is less than sign. Now, negative 1/3 times 6y. Okay, in parentheses. And then what's a negative times a negative? Positive. So I have 1/3 times 3. So this is what it looked like. And in red here, I'm going to start showing you what happens. Technically, all of these are over 1. Okay, they're technically all over 1. It's just an understood 1. That's it. What does that mean to us? That means when I start multiplying straight across, because these are multiplied together, I can multiply straight across. So that's what I'm going to do. I'm going to show you something, okay? I want you guys to get really strong with your fractions. What's 1 times 6y? 6y. What's 2 times 1? 2. What's 1 times 2? 2. What's 2 times 1? 2. I'm just going straight across here, guys. 1 times 2, 2 times 1. Minus 15 is always just chilling. Oh, that 15. Oh, you weird guy. All right, straight across. What's negative 1 times 6y? Negative 6y. Divided by 3 times 1 is 3. What's 1 times 3? Plus 3. What's 3 times 1? 3. You see how I'm working with the fractions here? Now, watch. Ready? Ready? Watch. What is 6 divided by 2? Does it matter if there's a y here? No. It does not matter if there's a y there. Okay, I can still divide the fractions if I want to. What's 6 divided by 2? It actually becomes 3, and then the y tags on. What's 2 divided by 1? It's just 1. Oh, minus 15, just chilling. What's negative 6 divided by 3? Negative 2. What happens to the y? Tags on. 3 divided by 3? 1. Boom. Just eliminated all the fractions. Okay? Now, some of us can honestly do this in our head. We can just distribute through and we can already jump down. That's going to be 3y, that's going to be 1, and so forth. If you can't do that, then by all means, write it out just like I did. Okay, but trust the math. Trust it. Just like a language. You trust English language, right? You know what words mean. If you know how math and what it means, you're solid. All right, let's combine stuff here. I can combine that on the left side, 3y minus 14, less than negative 2y plus 1. What can I combine? Well, I can take the 14 and move it over to the other side, and I can take this negative 2 and move it over to the other side. So I'll finish it over here. I hope that's okay. So what will I get? I will get 3y plus 2y. Why is it plus? Because on one side of the equation it was negative, and I'm moving it over on the other side of the, inequality, not equation. I'm moving it to the other side of the inequality to make sure it combines with this y. So that means I change the sign. Does that mean I change the inequality sign? No, because again, we didn't multiply or divide yet, and we only flip the inequality sign if we multiply and divide. We did not multiply and divide, so I don't need to flip the inequality sign. Now, it's still going to be less than. Now what's going to be here on the right side, 1. I have a negative 4, so instead of minusing it over, I'm going to plus the 14. Because again, it needs to go poofy on this side, So if you really do want to see that plus 14 go poofy, and then this is plus 14, you can. That's what I'm doing here, okay? That's what I'm doing. 2y plus 2y plus 3y, yes. What does that equal? That equals 5y. Less than, what's 1 plus 14? 15. How do I do this? Divide by 5, because that's multiplication. Am I divided by a negative? No, I'm not. So I don't need to flip the sign. So this is y is less than 15 divided by 5 is 3. That's my final answer. Fantastic. I'm going to erase some of this stuff on this side so that I can start doing 3, 4, 5. So go ahead and pause if you haven't yet to do that. All right. I know, they don't give me a big enough eraser. It's kind of annoying. How's your guys' day? My weekend was okay, by the way. Thanks for asking. Appreciate it. Hope your classes are going okay. If they're not going okay, that's a problem. You should probably talk to your advisor or teacher. But you guys know you still have an advisor, teacher, and a mentor, whatever, mentoree. Don't forget. Don't forget. All right. Let's get rid of this arrow. I don't want that arrow. All right. I think that's good enough. All right, let's do 3. What does set builder notation look like? The set of all, not x. Oh, shoot. Why is it not x, kids? What's the variable? Y. The set of all y such that y is less than 3. Perfect. 4, number line. Let's do a number line here. Perfect. What is this? Let's do a 0 for reference, and then 3. Okay, is it equal to? No, it's not. So I'm going to do an open dot. Which side is it pointing? It's actually pointing this way to the left. So that means I'm going to shade everything to the left. Okay, and then let's do 5 in red because it's probably the most important step. Where does the graph start existing? Now this is a little bit different. We read math left to right. Yes, we read math left to right. So where does the graph, the shaded area, start to exist? You should be thinking left. It starts to exist all the way over here, right? Does this go on forever, yes or no? Yes, it does. Which means, is this positive infinity or negative infinity? It is negative infinity. So that means this goes from negative infinity, because remember, we're reading, like, imagine this graph goes on forever and ever and ever and ever. That shaded area would continue to be true, okay? And continue to be shading. And so as we're reading it left to right, as we're kind of trailing along, we start at negative infinity. As we're trailing along, these are still solutions. These are still solutions because it goes on forever. These are still solutions. What if this is negative 1? Is negative 1 a solution? Yes, because it's still less than 0. Now when I get to 0 here, oh shoot. Oh, I'm so stupid. Technically should be here. I hope you guys caught that. If you guys didn't catch that, darn. I just saw 0 and I was like, oh, I'm just going to circle it. Yeah. So we still got a little bit more to go. Okay, so this is 1 and this is 2. Are 1 and 2 part of the solution set? Yes, because it's still shaded here. Why is that? Because the graph stops when it gets to 3. Okay? Why am I using parentheses here? Because it's not closed. Okay? And again, sometimes you'll see this on Math Excel, like a parentheses there. Sorry about that 0. I didn't mean to confuse you guys. Just kind of scribble over it. That's not that bad. I've done worse in class, trust me. This is my domain interval. All right. All right, we're just going to town. All right, so let's erase. Let's do a couple more. I'm going to go through the whole slides. By all means, guys, you don't need to go and write down all of these notes. Just write down a couple of them, the ones that make sense to you. If you're like, I got it, I'm good, great. Make sure you get the summary at the end of the slides, and then I'll see you later. Do your homework assignment. I'm going to start going through these really, really fast and kind of explaining them fast now, okay? So negative 1 multiplied. So what do I have? I have 1 minus x minus 3. greater than or equal to. Now we have an equal to 4x. How can I combine? This can be negative 2, negative x. This will be 4 minus 4x. Okay. I'm going to take this over here. I'm going to take that and move it over here. So that means I have a 3x, okay? Because again, this will be a positive 4x right here. This is a positive 4x. That goes poofy. Positive 4x. Positive 4x minus x is just 3x. What happens here? This will now become a positive 2. This will become a positive 2. That goes poofy. What's 4 plus 2? 8. What's my inequality sign? Greater than or equal to. Got it? So far, so good? I hope. All right. So let's divide by 3. This is x is greater than or equal to 8/3. If you're like, oh my gosh, I have a fraction, that must mean I did it wrong. No. I don't know whoever taught you that, but it's not what it means. It means you have an answer. Okay, whether or not it's correct is a different story. Okay, what's your set builder notation? The set of all x such that x is greater than or equal to 8 all over 3. That's the first one. Okay, number line. If I have a number line right here, 8 over 3 is positive, so it's going to be all the way on this side of the 0. All right. So let's look at 8 over 3. Is it equal to? Yes, it is. So that means I'm actually going to do a solid dot here. Which way is it pointing? It's actually pointing to the right. So that means it's going to shade all the way to the right. Okay? And then sometimes you'll see a bracket here because remember, brackets mean included or equal to. Brackets mean included or equal to. So 5. What does that mean? That means we're going to see left to right, where does the graph start to exist? Does it start existing at 0? No. What about like 1? Does it start existing at 1? No. Okay, it starts existing at 8 over 3. And since it's equal to, I have 8 over 3 bracket. Where is it going to? Remember the comma is a going to. It's not an ordered pair. It's not an ordered pair. It's an interval notation set. So going to, where does it stop? Does it ever stop? No. So it goes to infinity. Why can't I use brackets on infinity? Because you cannot equal infinity. That's what that means. By the way, I'm going to make this really clear, explicitly clear, those of you who are actually watching all the way up to this point. When you have an infinity, it will never, ever, 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 never, 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 ever, ever, never, never, ever, never be a bracket. When you have infinity in your domain set, just like this, you will never, ever put a bracket next to it. Ever. Never, never. Aren't you so glad that you have a math teacher telling you straight up how it is? I hope so. Okay? It will always be parentheses on the side of the infinity sign. Okay? Whether or not it's negative or infinity. Also realize my positive infinity will always, positive infinity will always be on the right side of my set. Okay? I didn't mean to do that, but it will always be on the right side of my set. Okay? Always, always, always. If I have negative infinity, just like in the last example, if my negative infinity will always be on the other side of the set. Why is that, Mr. Carlson? I'm glad you asked, kids. Because we read math like a number line, left to right, left to right. All right, let's get started here. Let's erase. Boom, we're done. Wow, I thought I had another example. That makes me so happy. All right, so summary page. I am going to have you guys do summaries on your Cornell notes just because it is an avid school and because you need to be writing stuff. You need to be writing, making sure you're getting your inquiry and your W for Wicker. If you guys don't know what Wicker is, okay, it's this. It's actually an avid thing. That's an R. So that means writing. This means inquiry. This is collaboration. So I'm just going to abbreviate here, collab. This means organization. So I'm just going to abbreviate there, organization. And this means reading, read. Okay? Right here is your writing part. What we just did was the inquiry. Eventually, we're going to do collaboration. You should be organizing your notes, and you should also be reading your Math Excel homework assignment, as well as reading what this is. So in today's lesson, you learn how to evaluate algebraic expressions, solve linear equations in one variable with fractions. You also learn inequality symbols. Find the domain of an equation by evaluating interval notation, set notation, and descriptive notation, which is called set builder. All right. That was a blast from the past. I'm sure most of you felt, wow, I can't believe that was just Algebra 1. You learned technically all of that in Algebra 1. If that made no sense to you at all whatsoever, that is concerning, which is okay, which is why we have tutoring. So you need to come to tutoring with me on Fridays, 10 a.m. to 12 p.m. as much as possible. Fill out that one-to-one form. It's on Google Classroom on the classwork page underneath the online learning setting. That one-to-one form, just ask for me and then fill out a specific time. Make sure the reason is specific that I need tutoring on this lesson, solve linear equations or inequalities. Or if you want to, you can come into the Google Meets tomorrow. If you're following along in the template, you can come tomorrow and just as soon as I take attendance and everything and everyone's starting to pop off, you can ask a question because I'll be there for a whole hour from 10 a.m. to 11 p.m. Not p.m., a.m., 10 a.m. to 11 a.m. Monday through Thursday. So hop on to the next day's lesson and then straight up say, yo, I don't get this. Can you go over this example? I will absolutely do that for you. All right, so a couple of reminders here. Just review your notes tonight. I hope you were taking notes. Highlight anything you don't understand. Put some question marks there. Come back to me. Ask me a question later. And then make sure you are reviewing your homework because this is technically review and you will have a homework quiz technically tomorrow. Or if you're feeling up to it, you can do it today as soon as you got all your notes down and everything. Okay, but I would highly suggest you do the homework first. Do the homework first. If you do the homework at 100% before you do the homework quiz, and I can tell if you do the homework at 100% before you take the homework quiz, I can tell which one you do first. Okay, if you do the homework first at 100%, then you take the homework quiz, I will give you up to 2 extra credit points on the homework quiz. Now, if you get 100 on the homework quiz and 100 on the homework, will I give you extra credit? Will I give you like a 12 out of 10? No, I won't. Capped at 10 on 10. Sorry. Okay. But make sure you do that. If you're not on Math Excel, get with me ASAP. Get with me ASAP. Please, please, please. Without further ado, this is C Squared Mathematics. I'm your algebra teacher, Mr. Carlson. I hope you guys enjoyed the lesson. If not, there's plenty of other lessons on my playlist that you can check out, as well as on Google Classroom from other awesome math YouTubers. Until next time, I'll see you guys.